the importance of river discharge measurement. How are we going to use these discharge values? This let me again say you that whatever we are measuring in a river at a particular cross section, it is basically a raw data or it is a observed data. It is not a final data. It is a data which are not going to be directly used in the field of hydrology, in the field of flood forecasting, in the or we are going to flood frequency. These data are not going to used directly. Rather, what we do, the next sheet that I am showing you is a bit important one. Here you see these dotted points are the observed value. These dotted points are the observed value. I am again emphasizing these are the observed value. And for example, if someone asks you what is, and on this in this particular graph chart, on the x-axis I have kept water level, and on the y-axis you might be seeing a discharge value. Now suppose someone asks you what is the discharge value for a particular water level, what a discharge value corresponding to a particular water level. For example, let me ask you for this particular point water level, what would be the discharge value? There are two discharge values corresponding to this water level. So if someone asks you what is the discharge value for this particular water level, what would be your answer? Whether you will reply pick this discharge value or you are going to pick this discharge value. Similarly, for this, you see, water level remains same, but we have two discharge values, one here and the second one here. So which value you are going to adopt? So obviously, we are not picking up this value for any further calculation. What we do, we plot a rating curve. We also call this process as a fitting of rating curve. And this middle line, the darker black line is the equation that relates this water level to the discharge. Here y is your discharge and x value is the water level. So I have fitted a rating curve based on this absorbed discharge value, and that will give you this darker black line. This darker black line. So now there is no ambiguity. Once someone asks what is the discharge value corresponding to a particular water level, we simply go up and pick up the value, discharge value on this darker black line. That will be your discharge value, representative discharge value, and that discharge value will be used for any hydrological analysis, whether it is a flood frequency analysis, whether you are going to carry out the design flood, whether you are going to conduct any flood embankment. For example, you are picking up the discharge value for designing a flood embankment. So or total water availability in a year, if you are assessing the water availability throughout a particular monsoon year or water year, then all these discharge values are picked from this rating curve. These raw data, these observed data are not directly used. So my point to show this curve is that whether you use this mean section method or mid section method, this will only put a value and occupy its place on this chart like this observed values. But final discharge value will always be calculated from this rating curve, the rating equation. So if there is any minor difference in your calculation, whether you use the mid section method or mean section method, it is not going to affect, it is not going to influence your final discharge picking up for any further hydrological analysis later on. It is not going to affect much. So as a course designer for this particular module, my emphasis to each and every participants is wherever you are engaged in your respective field, try to guide your measuring team that they be as accurate as possible to measure the depth at the particular vertical, and they should be as accurate as possible to find out the correct velocity. But beyond a certain point, they cannot measure this velocity or depth very accurately, because nobody knows whether the current meter that you have lowered at 0.60, it is exactly at 0.60. It may sometimes be up, it may sometimes be lower than that. Again, here in cross section, you are seeing that the profile moves like this. But in real world, the river profile, how it is reflecting between these two particular, nobody knows. In picture, in this diagram, it is very simple that it is joining like this. But in real world, it may be zigzag way. It may be in between these two verticals, the cross section may be that this depth might be more, or there may be some higher ranges or higher water river geometry in between these two verticals. So we, no matter how best technique we may adopt, how accurate we would be in measuring the depth as well as the velocity, true value we cannot achieve. There would always be some sort of error in our measurement. So let me very briefly give you. There are three types of kind of error: manual error, systematic error, and random error. So once one would try to minimize the manual error and systematic error, but random error we cannot minimize. In fact, I request National Water Academy to prepare a module where we can discuss a little bit about the manual error, systematic error, or random error involved in discharge measuring technique. In fact, we are planning to update these modules. And when we will update these modules, we would like to cover some of the paragraphs, this aspect, what are the possible errors that may slip into discharge measurement. So this is how the discharge observation and calculation are made, and what would be its final destination. Final destination of all the raw data or discharge data is like this. Now, some of you maybe wishing to may wish to know how these calculations are done, how these equations are achieved, how these equations are developed like this. What are these lines? These two lines. What are these again? These two color lines on either side of these blank. These are very interesting part of fitting of a reading curve. And anyone who is engaged in discharge measurement or fitting of reading curve, they should know it. But during this webinar, it is not possible to explain all these things. But those who are desirous to know everything and all these things about it, know, later on we can share it. We have a lecture note I can share with the participants. They can go through this that lecture note, and they can themselves try to develop these lines, and they can also understand what are the importance of these lines while fitting a rating. Very interesting one, very interesting one. So my objective was to show you that the discharge measurement and its calculation, the topic is not going to end. The matter doesn't end here, but much more beyond exists. And before we use the discharge data for our design flood calculation or flood frequency analysis and all that, we have to carry out this exercise. And this is another important one. Now I will close here this PPT, and I will share this calculation sheet, because some of you were facing little bit difficulty while you're completing your assignment. as pointed out by Pandeyji, that in this particular example sheet, RDs, depth, and velocities are the observed value. Obviously, the RD we fix by different methods. Depth are observed at different verticals, and velocity are also observed either at the surface or at 0.6 d. Based on these three inputs, we calculate the discharge calculation for that particular section. So in this particular Excel sheet, each cell give you how these calculations have been performed. And already Pandeyji has given you, once you place your cursor over here, this small tiny triangular part, it will pop up before you a box where the calculations involved in this particular series, this column would appear. So you one by one go on that, understand it, and then you can perform it. What was missing in this Excel sheet that have been given to you on the platform, where these in the assignment instead of 0, we have given you certain depth. That assignment is a simply hypothetical one. Let me open that assignment sheet. This is a simple hypothetical discharge values, this RDs, depth, and velocity. This is, I am audible, Pandeyji?
Yes, you are perfectly audible.
Okay.
Only request was there was a request that midsection method can be revised in brief again.
Okay.
There was a request.
Okay, I will come to that before concluding. Okay.
Okay.
So this assignment is a simple hypothetical scenario that we have captured here. You might be observing, those who have gone through this particular assignment, you see the segments are not at equidistance. Segments are at irregular interval. Here you see the between these two near end, this near end, far end RDs, all the segments are equidistant, are equally spaced apart. But in the assignment, these are irregularly spaced. So the point to keep this at irregular spacing is only to highlight how these calculations are made, what formulas are embedded behind calculating this C. So whether your verticals are equally spaced or whether it is not equally spaced, it is not going to make much difference. So this is what I wanted to highlight while giving these verticals at different intervals. Similarly, here, instead of your discharge calculations in the previous one, we have given a certain depth. Not only depth, but we have also given you certain velocities. Near end, the same is true at the far end, right? At the far end. And that makes a little difference from this calculation sheet. So everything will remain same. It is, if you adopt the formula here, if you adopt this, nothing is area, because formula has been chosen in such a manner. It will give you a correct segmental area and total cross-sectional area for this sheet, for this assignment. But what is left in our the sheet that has been uploaded on the course forum is not accounting for these verticals. Here it is 0 on either side. It doesn't make any difference when we calculate the area weighted perimeter. But in assignment, we have given these two verticals at either end, certain value. That value we have to add in the total weighted perimeter. So suppose you are getting something here, weighted perimeter here value in that assignment sheet, you have to simply add this depth also, 1 meter here and 0.6 meter here. So whatever you are getting in your calculation sheet for this particular parameter, weighted parameter, you will have to add this one and 0.6. So suppose in the real world, you are facing a problem, you are facing a scenario where there is a certain depth at either end, river bank, then you can add that value with your weighted parameter cell. So that is how you can calculate the weighted parameter, and otherwise your discharge calculation, your segmental area calculation will remain same, because the cell has been defined in such a manner that it accounts for different scenarios as well. So I hope you will be able to carry out this exercise as well. In this discharge calculation, if you are able to see this particular sheet, though this method is not available in the sheet that we have uploaded on the course module, but I have tried here in order to emphasize how mean section method. So you see, you might observe that area remains same. As I was talking about while presenting the PPT, I was emphasizing this point, cross-sectional area remains same. It is not going to change. But you may observe the difference between discharge value. For this example, in real world, it may vary with different degrees. So here, it's a method giving you a little bit higher value, resulting in a higher discharge calculation, 41.33. And if you use this, if you employ this mean section method, that will give you 40.30. It's slightly less value. But again, let me emphasize you, let me again put this point before you. This discharge calculation, this discharge value is your raw data, is your observed data. It will only be a scattered value when you plot a rating curve, when you plot it on a gauge x-axis and y-axis plot, and if you try to find out or try to fit a rating curve, that these would be treated as a raw data, observed data. Final data, or the data that will represent the discharge value of that particular river, of that particular section, would be picked from the, or would be estimated from the rating curve, rating equation, or that black dotted line. So if you are getting a little values here, little bit, suppose minor, if differences are, you are finding it with your colleague or with your second partner, it is not going to make much difference. What is important is always emphasize, always ask your measuring team, discharge measuring team, that they should measure this verticals position as accurately as they can, as accurately as they can make the depth measurement at verticals, and as well as the velocity. These are the function that the measuring team in the field, the real world, they carry out. So always encourage those people that your instrument should be correct. What for discharge measurement, that should be properly in order. And segmentation, any method that you might have been adopting for this segmenting or for fixing your verticals, 10 meter, 15 meter, it should be as close to your method as possible. Suppose you are using a pivot line method, so those who are holding the flags on one bank, another one at the second point, and you are trying to coincide both the lines in order to fix boat in the middle of a river, that should be as accurately as possible. These are some precautions that one has to take in order to measure these values very correctly. They can, no, again I am telling you, they can try their best, but they cannot find the true value. They cannot find the correct value what is the velocity at that particular vertical. It will always carry, it will always be influenced by some randomness, some random errors. It may be, let me give you a very simple way. If suppose today's water level is 10 meters. Hello, hello, I am audible. Hello, Pandeyji.
Yes,
Ah,
absolutely, absolutely.
okay. So let me give you a very simplest way, that for the example, today's water level at a river section is 10 meter, and your team came out with a measurement of 100 cubics, 100 meter cube per second. Today's water level is 10 meter, and he comes out with a value 100 meter cube per second. Next year, same next day, same instrument, same manpower, again goes for the discharge measurement, and likely or unlikely water level is same. There is no change in the water level. What is your expectation of discharge value next day? Whether it will remain 100 meter or it will vary. So some of you might be saying that it may remain same, but some of you may also come out with a reason that it may be slightly higher, it may be slightly lower, and all this. So all the three possibility exist in the real world. It may come out to be 100, or it may come out with 100 point something more, or 102, or 99, or 99. But it is possible that it may not be same, though the water level remains same, because it is all because of the randomness. Nobody can claim that yesterday I measured charge particularly at this, I lowered my current meter particularly at this depth 0.60. Nobody can claim in the real world. So whatever we are observing in the river, it is raw data, observed data. Our effort should be to make those observations as correct as possible, and rest depends upon the officers or the staff who are handling the data analytical part, basically fitting of the rating curve and drawing certain curves on either side of the fitting curve. It is the job of those who have to conduct the data analysis. That is another way. But definitely my interest is that the National Water Academy in future update this module and cover this aspect of manual errors, systematic error, and random errors. So I close this Excel sheet here. Hope that you would be able to estimate the discharge using this calculation sheet. You will also be able to appreciate the methodology, the methods behind it, calculating it, and you will also be able to appreciate how correct one has to be while calculating this discharge. He has given me to ask me to discuss about this. Audible, Pandit?
Yes.
Okay. So let me come again to the midsection method. Here, this W is what? This W on the assignment sheet or that example sheet, how we are calculating. This W we are calculating half of RD of this vertical minus RD of this vertical. This is the total width between this vertical and this vertical. So half of this will come out to be this. So this is a 2W, and half of that will give you the W. But here in midsection, what we are doing, we are taking the half distance on this side towards this vertical.
Anupji,
yes.
This you explained, na? This has been the query by some. So
Okay.
again, emphasizes very simple. You have explained it very well, but just give some time on this. Why
Okay.
half? Why half? There are some questions to me on WhatsApp.
Okay. So why half? The formula that we have taken on that Excel sheet, you see RD of this line minus we have taken RD of this line. B plus I plus 1 minus B I minus 1. If this is your vertical I, then what we have taken in the formula? BI plus means RD of this line minus RD of this line. So it gives you total distance between these two RDs. Half of that will give you this one. Half of this will give you this width. Because this width we have not measured. We have actually measured this RD, this RD, and this RD. This RD, this dot, this thick red line, we have not measured. So in order to find out this, what we do, RD of this line, BI plus 1. If you put your cursor on that red triangle, then if you observe the formula again, then you will find out BI plus 1 minus BI minus 1. Difference between these, it will yield you this distance. Half will give you this W. So this W, this trapezium, this segment's width multiplied with the depth, here will give you the area of these segments. And once you multiply it with the observed velocity here, we are not averaging like mean section method, observed value here, it will give you the discharge of this segment. So this practice is adopted from one end to another end and go on carrying, and then sum up the discharge value would give you the total discharge by this approach, mid-section approach. If suppose there is still some doubt, then you are welcome to write it down on course forum. I can share with you some literature available with me that will give you much detail, much insight about this technique. So this presentation doesn't mean that our interaction or that our communication is going to be snapped right now. Even after this webinar is over, you can communicate with the NWA team, you can communicate with me through course forum, and we more discussion on that forum as well. I will also share this particular PPT on that course forum platform. I will also share my lecture note that will give you much insight about the errors that are associated with the measurement, discharge measurement. And those who are desirous to know much beyond, even beyond that, how to fit a rating curve, that kind of calculation is also available with you. I have an Excel sheet with that with me. I can share with you, and you can also familiarize yourself with that kind of thing. So there are much more available in the literature that are much more available with me also, that can be shared to you if you are interested in that. So I am just stopping it, this PPT, and let me see you the certain queries. Where are queries, Pandey sir?
It is in chat. Also, I request all the participants, they can speak directly also. They can on their mic and
Yes.
speak directly, or they can ask through chat. The one query I had received was why we are taking half, that you have already explained.
Yes.
So anybody wants to ask anything related to the assignment? They can directly ask here or write in chat. Unmute your mic. Unmute all. Have unmuted all. It may cause some disturbance, but still everybody will be able to ask.
Yes.
May kailangan ka pa rin, no? Ikaw ko nga pinapit dyan, magkuha ka nga ng, ayan.
Mute on कर दीजिए खुद ही करें क्योंकि कैसे okay those who are asking one participant was asking something, he can unmute his mic. वो फिर म्यूट ना हो गया, बोल रही थी उसको पता भी नहीं चला किधर थी अल्बार्डो
Pandey, I request you. Hello.
Anuji, there is one query in chat.
Yes, velocity is given at 0.6 d, then how to calculate it at certain interval RD? In fact, velocity is measured at, traditionally, velocity is measured at 0.6 d at each vertical. The verticals are defined by the measuring team themselves. They have to fix the intervals, at what interval they have to measure the depth as well as velocity. So velocity is not given. You have to measure it. You have to measure it at 0.6 d. I have already pointed. I have already pointed you out. Pandey, you can mute it because it is echoing.
Okay.
Yes, right. Okay. So velocity is not given it because it is a measuring team. They have to define how apart their each verticals would be, where they are going to measure the depth as well as velocity. Once they define their verticals, then there are different approach to position your boards or whatever the measuring this board or catamaran, whatever the equipment that you have might be having at your river section. You have to position your board accordingly, according to your interval that you have already fixed. You reach that particular vertical, and by using your measuring devices, you have to find out what is the depth at that particular vertical. And after that, once the depth is known, then 0.6 depth of that particular vertical, you have to lower your current meter. You have to position your current meter at 0.60, and that will give you a value that commonly assume that this is the average value of that particular vertical, of that particular average value. It may not be again true. It may not be again true. But after having a wide range of analysis, a wide range of calculations across the world on different rivers, it is assumed, it is seen that average velocity is measured at 0.6 d. So we lower the current meter at 0.6 d and we calculate it. It's not given. Once it is calculated, that the same is reflected in your discharge sheet or whatever the sheet that measuring team maintaining at your site. Any other question? I again request participants to use course forum as much as they can.
Any other query? You can unmute yourself and speak. So should I assume that everything is clear?
Yes, one question is, what is this river overflowing over which? Whatever river is flowing over a bridge or over a, you see the in a dam over your spillway. All that, there are so many formulas. Some of them are empirical, some of them are having certain coefficient defined for that. Those formula are used in order to find out what is the discharge over a section, over some weir or barrages, passing through the barrages or river overflowing over a spillway like that. So where at those cross sections we are not going to use our this area velocity method. Area velocity method is best suited for the river discharge, not for measuring overflow over the bridges. You can refer to different books. You can refer to different books for finding out what is the appropriate formula to find out the river discharge. But the person, Mr. Vijay Kumarji, if you are interested, you can refer to the technical reference manual of HECRAS. It is freely available. HECRAS is a software developed by US people, US Army Corps of Engineers. And if you refer to that HECRAS, it gives you a plenty of formula for calculating the river, calculating the discharge passing through spillway or any over section.
Okay, sir. Thank you, sir.
Anupji, there is another query. It is from Nepal.
I'm looking. This is a very important. Sagar Misra ji has written over there. When there is a high flow, obviously, when the condition is very much hostile, it is unfriendly. A river measuring team cannot go across the river in order to river discharge. So this is the point where if you have a rating curve with you, based on the absorbed data that you have measured in past. If you have fitted a rating curve, you have a rating equation, then measuring water level is very easy. Whatever be the discharge, how difficult how difficult the scenario is on a particular day, where your measuring team cannot go in a river to measure the discharge. In that scenario, you just simply measure the water level and use that fitting of this rating equation in order to calculate the discharge. That is one way. The second one is you can use that slope area method. Slope area method, again, where you need not go across the river, only you have to measure the river slope, and based on the values that you have already calculated, already estimated for at your side, using those parameters, values, for example, rugosity coefficient, cross section for that particular water level. Based on that, you can calculate the slope area method and use slope area method in order to estimate your discharge value. But when the river is even in spate, it is even you are not able to find out the you can use your slope area method. It is not possible. Then again, there are ways to extend your rating curve beyond a certain limit. You can extend your rating equation beyond certain level and use that rating equation in order to find out the discharge when you are not able to measure the discharge. So there are ways, there are plenty of material available which will help you out to find out discharge value in any section, even under difficult situation.
Anupji, there is a question from Mr. Mausam Bhandari.
Mausam Bhandari, yes.
In chat.
Yes, yes. If you measure the discharge just downstream of bridge, it is necessary to reduce the area of bridge. Yes, if you are measuring the discharge just downstream of your bridge, then it is obvious it would be because due to the presence of piers between the abutments, it is certainly going to increase your velocity. Your cross-section area diminishes, it reduces, and in order to maintain that same discharge, both in upstream and downstream, velocity increases. So obviously, when you measure the discharge, so you have to deduct the Pierce area in order to find out the correct discharge, representative discharge at that particular section. In India, we have different sites where sometimes in a year we have to take the discharge values just downstream of the bridge in order to have a record. You were right in that approach. Any other question?
Any other query related to that assignment also? You can ask. And you can unmute. Nobody has so far unmuted his speaker. Everybody is asking in chat. So can we assume that queries are, in fact, the presentation was very clear. So I hope most of the queries have been answered. And in addition, the queries which were put here that have also been explained. So should we close it now? Can we close the webinar? Anybody? I think Anupji, it is sufficient.
Yes, but let participants know that our communication is not going to end here. If
Yes.
there is still some queries, some doubts lingering on in their mind, they can still use course forum. We encourage them to use a course forum, raise your questions not only related to this particular topic, but they can also raise questions related to other topics also, and we would be happy to respond to that.
So thank you, Anupji. Thank you very much. It was a very enriching experience, and this webinar has happened for the first time on a particular assignment. Normally, we do the webinar at the beginning and at the end. But I think it must have been very useful to our participants in getting things cleared. And still, if somebody has any doubt, they can ask through course forum and also through WhatsApp. There is no restriction on that. We will try to answer those questions. Thank you very much. Thank you, Anupji, very much. Thank you, Bhatt sir, who has been from behind managing all the show. And thanks all the participants who have come and joined during office hours. And in case of other Asian countries, it might be even lunchtime, perhaps. So I wish to express our gratitude to all of you and happy learning, and keep the good work going and finish all the pending work this week. Thank you. Thank you very much.
Thank you. Thank you, Pandey ji. Thank you. Thank you.
Thanks.